In the world of math, some ideas are so fundamental they're basically the air we breathe, and the function is definitely one of them. We bump into them all the time, but what are they really? What are the strict rules that separate just any old connection from the incredible predictability of a function? Well, let's break it all down.
So here's the big question, right? We know all functions are a type of relation, which is just a fancy way of saying a connection between two groups of things. But not every connection makes the cut. There's some very strict rules, a kind of code of conduct that a relation has to follow to earn that special title of function.
That's exactly it. You know, if you think of all the possible relations out there as one big kind of chaotic family, functions are the disciplined ones. They're the ones who are always on time, always predictable, and they follow the rules to the letter. They're a very special, very disciplined part of that family.
So on one side, you've got the wild world of relations. Any link at all, it can be messy, it can be complicated, anything goes. But on the other side, you've got functions. They operate under a strict code of conduct, and that's exactly what makes them so powerful and so reliable. So, what is this code? Well, it really just boils down to two golden rules.
The first rule is all about participation. I like to call it the no element left behind rule. And trust me, it is absolutely non-negotiable.
Here's the deal. If you have a starting set of inputs, which, by the way, mathematicians call the domain, every single one of them has to be used. There are no slackers allowed. No one gets to sit on the sidelines. Every input must be mapped to an output. No exceptions.
Okay, check this out. This is a perfect example of that rule getting broken. In set A, our inputs 1, 2, 3, and 4 are all connected to something. But look at poor old number 5. It's been left out, just hanging there with no connection at all. Because that one element was left behind, boom, this relation is disqualified. It is not a function.
Okay, let's move on to the second golden rule. And honestly, this one is arguably the most important. This is the rule that unlocks that powerful predictability we've been talking about. It's the one unique target rule.
And to really get a feel for this rule, there's this great analogy that helps. Think of the inputs as archers and the outputs as targets. The rules of functions are really just all about how the arrows are allowed to fly.
So let me ask you, is it possible for two different archers to hit the exact same target? Absolutely, of course they can. And in function speak, this means it's perfectly fine for two different inputs to lead to the same single output. This is completely allowed.
But what about this? Can one single archer with one single arrow somehow hit two different targets at the exact same time? No way. That's impossible, right? And in the world of functions, this is the biggest no-no. A single input can never, ever lead to more than one output. If it does, it's not a function.
Okay, we've got our two golden rules. So now let's put them to the test. What do you say? Let's see if we can spot a function out in the wild.
All right, first test case. Based on those two rules we just learned, no element left behind, and one unique target per input, take a good look at this. What do you think? Is this a function?
Let's break it down. Rule 1. Are all the inputs used? Yep, every number from 1 to 5 has an arrow. Check. Okay, rule 2. Does any single input point to more than one output? Nope. Now, you might notice that inputs 1 and 2 share a target, A. But remember, that's totally okay. It passes both rules. The verdict is in, yes, this is a certified function.
All right, ready for round 2? Take a close look at this one. Is this a function? And hey, if it's not, which rule is it breaking?
If we check rule 1, the problem jumps right out at us. The input 5 has been left behind. No arrow, no target, nothing. And even though all the other inputs are following rule 2 perfectly, it doesn't matter. You fail even one rule, you are not a function. So case closed. This is a definite no.
Awesome. Now that we're basically pros at spotting functions, it's time we learn the official language to talk about their parts. There are 3 key players we need to know: the domain, the codomain, and the range.
And this brings us right back to our first golden rule. Because a function must use every single possible input, its domain is super easy to define. It's the entire starting set. Every single element is included, by definition. Simple as that.
Next up, we have the range. The range is the set of all the actual outputs that a function gives you. So think of it this way. It's the collection of all the specific targets that were actually hit by an arrow.
This table lays it all out just perfectly.
First, the domain is our whole set of starting inputs, -2, -1, 0, 1, 2. Then we've got the codomain, which is the entire universe of all possible outputs, in this case, every number from 0 through 6. But the range is more specific. It's only the outputs we actually get when we use the function. So for these inputs, the only results we get are 0, 1, and 4. See that? The range is a specific little part of the much bigger codomain.
So what's the big takeaway from all this? Why have these strict rules in the first place? Well, it all boils down to one incredibly powerful idea: predictability. When you use a function, you have an absolute guarantee. For any single input you give it, you will get exactly one repeatable, predictable output, every single time. And that rock-solid reliability is what makes functions the bedrock of math, computer science, and so much of our world.
And that brings us to a final thought. Functions bring order and predictability to complex systems. So think about your own daily life, from your coffee machine to your Wi-Fi signal. What's one system you use every single day that you just wish worked with the perfect, predictable reliability of a mathematical function? I'll leave you with that.